Lecture 4. Stability and shelf life. What's the meaning of stability? Stability is the ability of a pharmaceutical product to retain its physical, chemical, microbiological, therapeutic, and toxicological properties that it has at a time of its manufacture throughout its period of storage and usage. Decomposition pathways of drug. The drug may be decomposed by many pathways like hydrolysis, oxidation, isomerization, epimerization, photolysis, molecular hydrolysis, and ionic hydrolysis, proteolysis. Examples of drugs to be hydrolyzed, which have groups like ester or amides. Esters like aspirin, procaine, atropine. Amides like chloramphenicol. Aspirin can be can be hydrolyzed by catalyst hydrogen ion or hydroxyl ion at a pH of 2.4. It will be of maximum stability. Procaine can be hydrolyzed by a catalyst of hydroxyl ion. The pH of maximum stability will be 4.1. Atropine can be hydrolyzed by hydroxyl ion over pH of 4.5 or hydrogen ion below pH 3. Amides like chloramphenicol can be hydrolyzed by a catalyst like phosphate or acetate or citrate ion, but it is pH independent. How to protect from hydrolysis? We can protect from hydrolysis by adjusting pH using selected buffer. Example, by bilocarbene buffered at pH 5, it will be very active and stable. It is also hydrolyzed rapidly in alkaline solution. If pH over 7, it will be hydrolyzed rapidly. We can protect using complexation between epinephrine and plasma proteins, benzocaine complex with caffeine. We can protect also by suppression of drug solubility using ester free form to suppress drug solubility, so it will not be hydrolyzed, or removal of water, dry mix or non-aqueous vehicle. This will protect from hydrolysis, or micellar surfactant protection using surfactant. Oxidation also can hydrolyze or can decompose drug. Mechanisms by removal of electron or loss of hydrogen or reaction with molecular oxygen or free radical and chain reaction or free radical mechanism. A free radical is a molecule or atom containing one or more unpaired electron. They tend to take electrons from other substances causing their oxidation. Oxidation reaction depend on concentration of oxidizing agent, which will, if increased, it will increase the oxidation rate. Heat, light, pH, trace amounts of heavy metals. Heavy metals increase oxidation. Oxidation reduction potential of the drug. The oxidation reduction potential of the drug, if increased, this means that the reaction will be very, very difficult. If the oxidation reduction potential decreases, this means that the oxidation will happen easily. How to protect against oxidation? We can protect by removal of oxygen by bubbling nitrogen, which is inert gas, or helium during filling of the solution, or buffering the oxidizable drug solution to an acidic pH. Acidic pH will protect from oxidation. Using a solvent free from heavy metals by using a chelating agent like Edita, or filling the drug into amber colored glass or opaque plastic container to protect from light, which catalyze the oxidation reaction. Or using suitable antioxidant, easily oxidizable substance which has a lower oxidation reduction potential than the drug, so it will be oxidized instead of the drug. Examples of antioxidants: we have aqueous antioxidants like sodium sulfite, sodium thiosulfate, sodium bisulfite, sodium metabisulfite, and ascorbic acid. Ascorbic acid, vitamin C is vitamin C. Oily antioxidant like hydroquinone, butylated hydroxyanizole, butylated hydroxytoluene, and alpha tocopherol, which is vitamin E. Mechanisms of action: preferential oxidation, like consumable antioxidant like sulfide group, or a chain reaction propagation termination non-consumable, it stop the chain reaction, or by blocking an oxidative chain reaction caused by free radical like ascorbic acid and tocopherol. Stability and shelf life stability, we said its definition before. Types of stability may be chemical, when we said chemical integrity and labeled potency, or physical like appearance, palatability, dissolution, or microbiological like sterility, or therapeutic when we talk about activity remained unchanged, or toxicological, no increase in toxicity. Chemical stability, importance of chemical stability, selection of storage condition to select the optimum storage condition, selection of proper container, interaction when drugs are mixed together or with excipients. Excipients are the material put in the dosage form but it has no pharmacological effect, like starch in tablet. Stability and expiration date. Most decomposition reactions are zero and first order reaction. Type of stability studies, it will be in the development or the manufacture phase. In the development phase, accelerated stability testing. In the registration process, accelerated and real-time studies. In post-registration period, it will be real-time study. We will discuss it now. Climatic zones to be known, climatic zones like temperate, subtropical and Mediterranean, hot and dry, hot and humid, it will be known by name only. Types of stability studies and testing condition. Number one, accelerated study. Accelerated study using stress condition to identify the weakness of an active ingredient or a formulation, prediction of decomposition rate, predict the effect of storage and transport at extreme conditions on the product. Stress condition, we can use temperature with a range of 40 to 80 degrees centigrade. Temperature increased in 10 degrees step starting from 21. At least three temperatures are used. We can use raised temperature and put the drug in an ovens to know how the drug will be decomposed and what the period it will be decomposed in. May be used for solid dosage forms or semi-solid liquid dosage forms. Frequency of testing, it will be at 0, 1, 2, 3 months and 6 months when possible. Then the second type, it will be climatic zone stability testing. We can put the drug in the 4 climatic zones we said before. And then there is number 3, long-term study or real-time or shelf stability, which will put the drug on the shelf for 5 years and take samples for analysis every 0, 3, 6, 12 months. At least the results of 6 months are required at the time of registration. Number 4, ongoing stability test studies. Samples are tested less frequently, every 6 to 12 months. Shelf time or shelf life estimation methods by using Garrett and Carver method. Garrett and Carver method, we plot concentration against time at 4 elevated temperature. From straight lines, we can calculate K from the slope. Then we plot log K against 1 over T, the reciprocal of absolute temperature. Arrhenius equation. We said it in the previous lectures. Extrapolate the result line to room temperature to calculate K at 25 degrees centigrade. Calculate the expiration date by the law. If 0 order, it will be 0.1 C naught over K 25, or it will be 0.105 over K25 if it is first order. Most of drugs are first order. Shelf life estimation method, the second method, it will be free and place method. It is like Garrett and Carver method, but with we change a detail. Using a liquid product used for liquid products, we plot instead of we plot concentration against time, and instead of calculating K from the slope, we calculate T 90%. We calculate expiry date. Then we plot expiry date log T 90% against 1 over absolute temperature or reciprocal of absolute temperature. From the straight line we can find T 90% at room temperature. We will talk about Cannon method. Cannon method can be defined by its name only, as it is used for activation energy of 10 or 20 only. So we can know it by name. Shelf life estimation method, Q10 method. It is very important. It will be discussed in tutorials. Q10 is a factor by which the reaction rate increase for each 10 degrees rise in temperature. For example, if Q10 is 2, it means that if we raise the temperature by 10 degrees, K will be doubled. K will be doubled. We can use the next law, which say T90 at temperature number 2 equals T90 at temperature number 1 over Q10 raised to power delta T over 10. The trick will be at delta T. Delta T can be calculated by, it is the difference between the second temperature minus the first temperature. We will discuss it in the next example. An antibiotic solution has a shelf life of 48 hours in refrigerator. Refrigerator is 5 Celsius, which is the estimated shelf life at room temperature at 25 Celsius. We can use it. The delta T will be 5 minus 25 minus 5. 25, the second temperature, minus the first temperature. 25 minus 5 degrees centigrade. And vice versa. If we put if we had the antibiotic solution at room temperature, then we put it in the refrigerator. The delta T will be 5 minus 25. Overage, the excess amount of drug. Overage is the excess amount of drug added to a drug product to extend its expiry date, or excess amount of drug added to a drug product to maintain at least 90% of the labeled drug claimed during the required shelf life of a product added during manufacture. Overage is used if the expiration date is too rapid. It is used for safe drugs, not potent and toxic drugs. It is used for safe drugs, as we can put an excess of the drug in the dosage form. Calculation of overage, it can be calculated mathematically. In case of first order reaction, log Ct equals log C node minus Kt over 2.303. We can substitute Ct by 90% and C node will be 110%. This is the overage. The overage is 10%. We can calculate overage graphically by draw normal loss curve at room temperature and determine the expiration date T 90%. Draw a parallel line to the previous one starting from the desired shelf life and go back to the y-axis. Determine the new drug potency if it is 110 and the overage is 10%. Limitations of accelerated stability method. Accelerated stability testing method has some limitations. We can't use it all over time. Not valid for proteins due to its coagulation. If we raise temperature, proteins will be coagulated. Used only for in thermal degradation, not suitable for degradation by freezing or contamination or microbial growth. Results of degradation obtained in one solvent can be applied to another vehicle. Apply to solids and solution dosage forms only. can't be used when suspension, as heating increase drug solubility, so the dosage form will be changed. It will not be suspension, it will be a solution. If there is a change in phases between high temperature and room temperature, a non-linear Arrhenius plot, or drug existing at different polymorphic forms, the drug has more than one polymorph, or emulsion which break down by heat. Prediction of stability is impractical in case of a change in reaction order or a change in activation energy, or when degradation is enhanced by a degradation product. Means metabolite used decompose the metabolite used as a catalyst to decompose the drug further. Thank you.